Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan, from the Simple Electronics YouTube channel. And with me today, I've got a very special guest. I've got Bill from the Uni-Byte YouTube channel. Oh, and by the way, this episode is brought to you by PCBWay. How are you, Bill?
I'm good. How are you?
I'm great. I found your channel by very odd circumstances. I was literally live streaming and I decided that I needed to learn about op amps, and I saw that you had a PCBWay shared project about op amps. And then when I saw that, a few of my chatters have said, "Oh yeah, I've been subscribed to the Uni-Byte channel for a while now." And I checked out your channel, and I mean, I was hooked from there. So I'm happy to have found you. But for those in the audience that don't know you yet, can you just let us know a quick little bit about who you are and what you do?
Okay. So, my name is Bill, and I've been doing electronics for a long, long time. Father was an engineer, mostly in the motion picture business. And his side of things initially was in the electronics side. He used to work for Westrex and a number of other manufacturers of motion picture equipment. And he taught me electronics very early. He used to do it, basically to get me busy with something like, here's Ohm's law, go figure out these values and stuff like that. And eventually got me into designing and biasing transistors. Back then, most of the transistors were germanium, so my knowledge from back then is not transferable to today, but once you get the ideas of it, you carry it along. And my first real job was in electronics, mostly working for my dad. He would take on a lot of side jobs where he would configure little studios for colleges and universities and stuff like that, and he'd have me out to do wiring and crawl through crawl spaces because I was small at the time. So I got a lot of really good practical experience that way. Later on, I took some courses at a college level, and I got my qualifications to become a certified engineering technologist, although I didn't go to the CET and write their exams or anything like that. And eventually, I got a job after high school because I didn't go to college full time. I eventually got a job with a studio that my dad had put together called Miraphonic Sound in Toronto. And he had left there, and he'd gone to work for one of the equipment manufacturers again. And I kind of worked my way through college at that place, being their electronics technician, fixing the audio consoles and the dubbers and the recorders and all that sort of stuff. And once I did get my education under me, I left there and went to work for a company called Xtel Communications up in Markham, and they were doing digital electronics because that's kind of where I was really interested. I'd done a lot of the audio stuff. I had done that for years, and I said, "Oh, this digital electronics is really exciting." And it was right about the time the first microprocessors were coming out, the 8008, the 4004, and the 8080, and so forth. And so I went up there to work for them, and they kind of had me doing this, this engineer's job because I had so much experience, but they weren't, the people there who actually had the engineering degrees and the professional engineers were getting paid twice what I was getting. So I kind of said, I'm going to go back to school. So I decided I would go down to the University of Toronto and see what my options were. And they said, "Okay, here, take this math course. If you do well in it, we'll let you in." So I did. Now, up to that point, I have to admit that I wasn't a great student of any kind. I mean, college, I kind of scraped through. I only did the subjects that I liked, and they're the only ones I did well in. And high school, I was just a wreck. I just don't talk to me about my high school. And but at university, it was different. I took a real interest in what I was doing. And I initially, after I did that pre-university course, that math course, I did so well in that they gave me a scholarship, which paid for my first couple of years of tuition and books, which was a real help for me because at that point in time, I was out on my own. My parents had moved away from where I was living, and I was basically supporting myself. So that was a real bonus. And I decided that, maybe physics would be the best thing to get in. It was more generally applicable. So I ended up getting degrees in physics and mathematics. And meantime, working my way through the university, I went to work for a company in Toronto called Cycle World, which were the largest motorcycle dealership in Canada. And what I did for them is I designed a computer system for them, for their parts and their sales and their inventory and all that sort of stuff. So, so I was on this road to getting my professional engineer's and getting an education in physics and mathematics, and I ended up becoming this IT person. So after my university was finished and I had finished my project over at PsychoWorld, I got a call from my cousin. He was working for a company that did demographic information systems. And they were having a problem getting one of their PDP-11 computers to communicate properly with a plotter and a printer. And I went over there and I fixed their problem in a few minutes. And their boss came by, and he was the kind of guy who really liked people who worked late. And we were there until like 10 o'clock at night. And he was so impressed. He bought us dinner, and he offered me a job on the spot. And at more money than I ever imagined possible, like at least 50% more than I would get as a professional engineer with my new credentials. So I took that, and I got into IT, and I guess that would be around about 1986 or so. And I stayed in IT right up until 2012. So I kind of left electronics. It was always kind of in the background, and I kept it as kind of a hobby that I would delve into from time to time. But after my career kind of ended in 2012, I got back more into electronics and started to just do it on my own at home, mostly just building microprocessors and stuff like that. Basically using old technology that I should have had the chance to play with all along, but didn't have a chance. Kind of redoing my roots and getting myself back into it again. And that kind of led me up to where we are today. So yeah, and it's just in the last year and a half or so that it's a year and 3 months that I decided to get onto YouTube and kind of share what I do, my hobby, with the rest of the world. And so that brings us up to today.
And the thing with your YouTube channel, so I often find YouTube channels by coincidence, but they're never as specifically tailored to the kind of things that I look for, which then again reinforces the fact that the algorithm isn't really feeding us our preferences. It's just feeding us stuff, that it'll get us stuck on one path, right? And binge watching videos. Because on your channel, there is a lot of, similar things that I'm into. So for example, you take a look at beginner electronics tools. That was about a year ago. You take a look at modules, you build your own, test devices, you make PCBs. You do all sorts of these things, but yet somehow, you have criminally low amounts of subscribers. I mean, you've only been at it for a year and some, but I feel like really you're behind the curve of where I think you should be. So I'm really glad your channel exists, basically.
Well, thanks for that. Yeah, I tend to agree with you. Like I'm just beginning to kind of learn, and you gave me some advice a little while ago about what I could do about my thumbnails and stuff like that. So that's really appreciated. And I wish I'd say some of my subscribers would give you a little bit more advice too on what they think I should do, because I'm always trying to solicit them for, if you have any suggestions, leave them down. And they have been a little bit more responsive lately to that. But yeah, mostly on the technical side. But I really would like to try and make the channel a little bit more well-known and get a few more subscribers. And I mean, it does, as you probably noticed, I'm also sponsored by PCBWay, as you are. And that's been a real boon for me, because most of that stuff that I do buy from AliExpress and stuff like that, that comes from the money that they give me for the the 1 or 2 videos I do for them a month. And it really comes in handy, because normally I would get focused on something, and it's something, a much bigger project. And a lot of those I haven't brought to my channel yet, because I kind of difficult to approach them. But I have, like, if you could see me right now, I have in my hand this little computer based on a 6502 microprocessor. And I'd like to get into, explaining this, how can you take something, just a concept of what you want to do with a microprocessor, and build it into an actual working thing. And yeah, I don't think I have the viewership yet to do that, and I'm still trying to attract people in by approaching things from a more simplistic point of view and get people more interested in it. But maybe I need to change that up a little bit.
I think what was her name? I'm trying to think of a creator. I want to credit the right person. Oh yeah, Sarah Dici. So Sarah Dici's a YouTube creator, and she had a video that really marked me, where she said her motto for her channel is "one for you, one for me," and that means that when she makes a video that she's really passionate about, that's something she really cares about, she puts it out there, and people tend to like things that people are passionate about. But then the next video will be something to sort of have more broad appeal, something that will draw people into the channel for them to be able to see her passion. Because if you do things passionately, that's fine and good. But if no one ever clicks on your passion projects, then it's kind of for nothing, right? If you're doing it. So she describes going through the process of making sort of evergreen content. So what kind of multimeter should a beginner buy? That kind of stuff is like incredibly enticing, because of the people who are like us and nerdy and, you know, solder things together, there is probably 100 times the amount of people who are just interested in knowing what it takes to dip your toe in. So that's a little bit how I try to run my channel and how I try to frame my videos, you know, like sort of the hook on which I hang a video is try to be discoverable and try to, you know, do my passion projects. So for example, my passion project is building, 3D printed RC vehicles, or experimenting with lithium ion batteries, and eventually making, you know, a full electric solar powered boat type thing. But in order to get there, there are components you're going to use. So like, for example, how do you charge or maintain a lithium iron phosphate battery? So that's a video that more people are interested in than my passion project. So I sort of use those videos as stepping stones towards the things that I'm passionate about, to bring people in and see if they're then interested in my passion. I don't know if it's 100% the right way to do things. I'm not like I'm no Linus Tech Tips here, but I believe that is how you get more viewership onto a channel, because I've seen your videos, and I hope the listeners are going to go check them out too. Link in the description, by the way. But they're good videos. They're very good videos, but it's just, it seems like you don't have enough people giving you a shot. You know what I mean?
Yeah, no, I agree with that. And you know what you're saying, that the one for me, one for you, that's something I'd be willing to give that a try too. That makes sense to me. You know, a lot of the things that I want to do, like that recent video I did on the Simpson 270. I mean, that I like that older equipment. I think that older equipment is still pertinent today. The newer equipment, all the newer equipment that we have today was designed using the older equipment. So it basically does the same job. And a lot of people kind of, you know, that they toss it aside. Oh, that old frequency canner or that old meter, or that, they're really good stuff, and they'll do the job. It's like I had a question from a friend of mine who's, you know, he's thinking about getting into electronics a little bit. I went to school with him for physics, so he's no slouch. But he wanted to get himself a function generator, and he was looking at, you know, $1,000 function generators, and I was asking him, well, what are you using it for? And he says, well, I want to get into, you know, maybe repairing old audio equipment. And I said, you don't need a $1,000 function generator to repair audio equipment. So I found one on eBay that he could pick up down in Toronto for $25. And it certainly covers the audio frequency range. It also has square wave capability, sine wave capability, triangle, and so forth. So he can test the upper end response of his equipment and stuff like that, the transient response and all that. And he doesn't have to spend $1,000. So, I mean, I do have a kind of a passion for keeping this older equipment going. I think it's worthwhile doing. One of my video series a little while back, I think it was 3 videos about getting an old oscilloscope, basically the big brother to the first oscilloscope I ever owned. It was a Heathkit. And I had some problems, and I went through it all and figured them out and got it all fixed up. And it's sitting there down in my basement. And I do use it from time to time. If I'm working on another series of videos I did was on a audio amplifier, a guitar amplifier that somebody had thrown out in the street here. And I looked at that and I said, you know, that it's got to be fixable. And so I took it home. Sure enough, it was fixable. And I used an old frequency generator and that oscilloscope to do all the repairs on that guitar amplifier. And it's for a lot of stuff. That's what you need. You don't need to go out and get the latest Rigol oscilloscope or signal generator and stuff like that. It's all a matter of being, having access to the right tools and being able to do it at a reasonable cost. And you don't need to spend $10,000 to put together an electronics lab. $100 could probably get you up and running.
These days, absolutely. And going back to, first of all, I am trying to whore out your channel to my subscribers. So there is that. But going back to your channel, like if I sort by the most popular videos, you'll see that the most popular videos on your YouTube channel serve a purpose. They provide a service. So your number one most viewed video is explaining that the high-elect power supply is no good. You have a picture. Your thumbnail is it in the trash can. And so that's one thing. Like people like you and I have done lots of research into what we should buy. We have an idea of what we should buy. But people dipping their toes in, they have no idea. So videos like that are a massive service to beginners. But for those that haven't watched your videos, can you explain to us what happened with the high-elect power supply? Like, why do you not recommend it?
Oh, there are a couple of things wrong with it. Most notable was the amount of noise. I mean, like this thing. When I turned this thing on with any kind of load on it, my oscilloscope the traces on my oscilloscope would come up, even without a probe plugged in. And this thing was just radiating noise all over the place. So I took, in the video, you'll see I took a look at the noise on the various loads. And at some points, the noise was as bad as the voltage. So, I'm putting out 5 volts of DC voltage. It had 3.5 volts of noise. Now, a lot of this noise was common mode, and I didn't go into that a lot in the video because I don't think a lot of people looking at a power supply like that would know the difference between common mode noise and differential mode noise. Common mode noise is not the kind of noise that the device you're working with will actually see, because it's both the positive and negative are got the very same noise signal on them. But what it does do, that common mode noise basically turns the device you're powering into an antenna and radiates that noise throughout your lab. So it's going to create noise in everything. If you had a radio on, you'd hear this squealing in the radio. And another thing it did very, very badly was its response to loads and things like that. Like it basically it was a bit of a wreck. And it also, the way that the power supply was designed, it had no route for stray currents. These are caused by capacitive coupling in the transformers and throughout the circuitry, and they can create these offset voltages. So when you measured that power supply with respect to ground, you could, I've forgotten exactly what it was, but I think it may have been around about 20 or 30 volts with respect to ground. And for a lot of things, like if you're just powering a motor or something like that, it's not going to make any difference at all. But if you were going to power up something that had like a JFET input into it, and then you power that up with that supply so that it's now floating 40, 45 volts above ground level, and then you attach up something that is ground reference, like an oscilloscope or a signal generator, then that junction FET or that FET is going to see that 45 volts with respect to ground. And it's unless you're using a very expensive high voltage FET, that's just going to blow your FET to pieces, right? And then you're going to create more problems. So, yeah, eventually I got through that. What I did is I put some Y type capacitors in between the output and the ground. I put in a filter to filter out some of the noise. And eventually, if you go through, I think it's 3 video series on that. The third one eventually ended up with a power supply that's usable. It's still not perfect by any means, but it is actually usable. I mean, we reduced down the stray voltages down to almost nothing. We reduced the noise, especially the common mode noise, way down. And but in my opinion, it's still a piece of junk. I mean, like, there's no way somebody who's got, I think what I paid for that was not what it's worth right now, but I think I paid like $28 or $30 or something like for that power supply. Somebody goes out and spends that kind of money on it, they shouldn't have like a huge project to take that thing and make it something usable and spend an extra $20 or $30 on components and all the time it takes to investigate what it would take to make it a usable power supply, especially for the beginner. They don't know. And they may get something like that and they may use it and it may actually just destroy more of their stuff as they go along. So, yeah. And a lot of that stuff out there is like that, and it's a shame in a way. There are unscrupulous vendors out there who will sell you something that looks like it'll do the job. They manufacture specifications for it that are nowhere near the actual reality of the device itself, and you buy it I see a lot of people getting discouraged buying equipment like that, and they spent their time and their money to get a little bit of electronics kit together. Nothing works. They just leave it alone, walk away and say, electronics is not for me. And that's terrible. That really is. To me, that's terrible.
And that's where like a channel like yours or mine could come in and help, like actually be the helpful voice, like, yes, buy this, and no, don't buy that. Like, for example, so that was episode 14, I think, was when you put out that the beginner's electronics tools about the power supply. But then by episode 21, you had a different power supply. It looks like kind of a generic power supply, AC/DC thing that you can source from Amazon or wherever. Was that any better? Just a quick interruption to talk about this episode's sponsor, PCBWay. PCBWay has been a long-term sponsor of the channel, and I think they're a good match for my channel because they provide quality PCBs for a reasonable price. You can get boards manufactured up to 100 mils by 100 mils for just $5, including shipping to Canada, $15 US, including shipping to USA, $12 US, which is incredibly cheap for professionally manufactured PCBs. I can personally attest to the quality of these PCBs, and so if you want a circuit immortalized forever, check out PCBWay.com with the link in the description. Now back to the conversation.
Oh, it's hugely better. First of all, it was a linear supply, and so its noise was, there's practically no noise. There was none of that stray voltage on it. And the only problem that I found with that power supply initially was that it didn't have very good heat sinking on the pass transistor. So being a linear supply, it requires a pass transistor or a pass element to dissipate the energy that you're not using. So let's say I think that was capable of producing up to 30 volts at 2 amps. And that's fine. If you're running it flat out 30 volts at 2 amps, then the pass transistor's not doing a lot of work. And the heat sinking that it had is basically just mounting it to the back of the cabinet. It'd be fine. But if you were to then say, I want 2 amps at 2 volts, then you've got to take 28 volts at 2 amps or 56 watts, and you got to dissipate that in heat. And that's when I found that, touching the back of the transistor on the back of the power supply in cases like that, it got so hot it would burn my fingerprints off. So the only thing I did with that one is I put a big heat sink on it. And luckily enough, I had one around here that fit the bill exactly. But I think that power supply was worth doing that too. Like, it was clean, it was accurate, and it didn't have any, these stray voltages coming out of the thing. It behaved very nicely in that respect. And all it really needed was a little help by putting a bit better heatsink on it. And, those heat sinks are not cheap, but I imagine you could probably pick one up for maybe $15 or $20 that would do the job. So doing a little project at home, I think that whole project took me about an hour of my time. I mean, I know the video was a lot shorter than that, but all I had to do is drill a few holes and do a little bit of wiring, and voila, the now is very, very usable power supply, and I still use it. I use it all the time. So yeah, that one was worth it. I mean, it cost a little bit more to begin with, but then the cost and time and money to make it a much better power supply was very little compared to taking the Hylec and trying to uncover all of its issues. I mean, at one point, I think in the second video, I tried to look into the drive of the output transistors and stuff like that to see if we can modify those, because sometimes they just drive them too hard, and if you back off a little bit on the drive of the output MOSFETs, then you can bring the noise down. But that didn't help, and it was just so much work went into that, and you can't see all the work that I did in the videos. But when I think, a beginner doesn't deserve this. But a beginner could use the other power supply, and if they weren't, drawing 2 amps and 2 volts out of it all the time, they probably never would run into the heat problem at all. But I showed in the fix-up video for that, it was a pretty simple fix, pretty inexpensive, and was 100% effective.
For those of you listening along at home, the episode is 0065, the one where Bill goes along and improves the power supply. And correct me if I'm wrong, but that heatsink looks like it's a heatsink that's actually designed for solid-state relays. Does that look about right?
Actually, you bring that up. I have used that heatsink for a solid-state relay, but no, it was designed as a TO3 package heatsink specifically, and the transistor on the back of that is a 2N3055 in the 2N3055's traditional package, which is a TO3. And I just love that transistor, which is another thing that I really like about that power supply. It's one of the best transistors ever made. I think if you look at Dave Jones' channel, he just recently did a video on jelly bean transistors, and he included the 2N3055 in there, and I gave him a big thumbs up for that. But it was designed specifically for 2N3055 transistors, but I've used it for other things. I got a case of those about 2010 or something like that. They popped up on eBay from a seller called Mill Parts or something like that. He basically just a guy who went out and bought piles of components from people and then sold them through eBay. And he had a box of these heat sinks, and I can't remember what I paid for them, but I'm pretty cheap, so I don't think it was a lot of money. And I've been using them for various things. And yes, one thing I did use them for was for a solid-state relay. I had to cut one of the fins off in order to make room for the solid-state relay. It was a big 100-amp relay. That was easy enough to do, but very effective for that as well.
So I've got a pitch for you. If you made a video titled A Love Letter to the 2N3055 transistor, and you went, 5-minute video, go over the brief history of it, where it's most used, and then design a circuit around it, explain why you like it, why it's ubiquitous, like literally 5-6 minute video, I guarantee you're going to get some good traction. Good thumbnail, nice macro shot on your cutting mat. I think you're going to do really well with a video like that.
That's something to think about. Yeah, I've got actually, I'll add that to my list of videos. What I generally do is whenever an idea pops into my mind, I've got this little text file that I open up and I put down, video idea. And I put that in there, and I'm going to put that in there too. I think that'd be very good, and might start. I already do like a chip of the month or component type video every now and then. I could include it in as one of those. But yeah, I do. I like that transistor. I like a couple of the other transistors Dave mentioned as well, like the 2N3904 and the 2N2222. They're just so, they're everywhere. You can get them for next to nothing, and they work perfectly well for most purposes. And, you see a lot of people have got their favorite chips, like especially in Europe, people like the BC series transistors. And there's a lot of those jelly bean transistors out there, and jelly bean regulators and op amps and stuff like that. And these are good components to get a good supply of, because they're readily available and they're very inexpensive and they do the job. And that's the reason they're so popular.
Yeah, absolutely. And this is how I found you, because you made a video on basically a jelly bean component, which is op amps. Can you tell me what the motivation for making a op amp experimenter board was?
Yeah, actually, I'll have to say it wasn't originally my idea. There's another guy out there with a YouTube channel. He's I like his stuff. He's a little bit strange. He's got a good viewership. I think he's up to about 100,000. It's called IMSci Guy, and he a few years ago had created one of these. Now his was a little bit different than mine. It took 2 op amps on it, and it kind of didn't have as many. It's not as versatile as the one I put together. But when I thought of, I was doing like a series of videos for PCBWay. So I was introducing people to 555s and basic transistor circuits. And then I went on to op amps. And I thought, what I should do for this is rather than get PCBWay to manufacture a fresh new board every time, I could get a bit of mileage out of getting them to manufacture a board. It kind of looks like, you see the circuits on a schematic for an operational amplifier, and puts the operational amplifier in the middle, and you can hook it up, whatever way you want. And it does specifically take a dual op-amp package, a standard dual op-amp package. So you could put a TL072 in there, a TL082, NE5 or 5332, or an LM358 or 741. Oh no, 741 wouldn't go in there. There's a dual 741. I've forgotten the number of it off the top of my head, but it would go in there. And then you just hook them up whatever way you want. And so that's where the impetus for that came from, was to kind of make something that beginners could get their hands on, and put together circuits that they can see visually look like the circuits that they see on the schematic, and test them out and play around with them.
Yeah, I think it looks like a lot of fun. Plus, so I think I've said so in the pre-show when we were chatting, but I've tried to learn op-amps for a long time. And Dave Jones has a fantastic op-amp tutorial video, and this was obviously before I found your channel. But the thing is, I don't think I learn well with just theory. I need practice. But the issue with breadboarding op-amps is that you've got wires going a little bit everywhere, and especially if you use just the regular like DuPont jumpers, it kind of obscures which pin is doing what. So I have to like move the wires around and see, oh yeah, where did I probe here? Okay, what's this one doing? And I think at the same time there's a lot of overhead to understanding what's going on, because I know that like in theory what is happening, but I can't put two and two together. So I think the next PCB design that I work on, when I order my boards, I'll order a set of your boards as well, and of course I'll then promote you again on the channel. But I think it'll be really nice to have a play with op-amps in a very clear and kind of discrete way. So I'm really appreciative that you built that, and I'll be following your tutorial videos on the op-amps as well, because I need both. I need the practical and I need the theory.
Right. I got a little bit, I think it was the second or third video I did on op-amps, and I got into differentiators and integrators. And I went through a little bit of the theory on how you derive the formulas, and that kind of got met with a little bit of, oh, I don't want to do all that math kind of thing. But I mean, it is important, though. I mean, it's quite important, I think, anyway. And it just could be the physicist in me, coming out. But I think it's important to understand the model behind what you're working with. And that way, when things go wrong, you have a much more intuitive idea, because you do know the model of what you've gone and done wrong and how you could correct it. But if you ignore the mathematics completely, and I see this a lot in using finger quotes here, the maker business. And that, when I talk about the maker business, I'm not talking about the kind of stuff you and I do, but more the Arduino guys, the microcontroller monkeys. They do things that they see that other people have worked on, and they just copy them, and they don't get any understanding. And so you'll see them a year later on the Arduino side, or the pickaxe side, or something like that in the forum, asking the same questions they asked before, or asking the same questions that come up all the time. And you get a lot of the more seasoned people who have done the work. Sometimes they're not all that friendly, and saying, they make comments that are maybe not that helpful, but I can see where the frustration comes from. That, like, I don't want to scare anybody away from electronics, but other than doing differentiators and integrators, you don't have to usually get into calculus a lot. Usually the mathematics is fairly simple. It's just basic algebra. But once the voltage divider formula, it's something that kind of gets engraved in your head. You don't have to ask the question over and over again. Just learn that simple formula, and forevermore you'll be able to know how to set up a voltage divider. To me, it's very important to know a little bit of that theory and the practical side of things. And that theory adds a ton to the practical side. It makes understanding of it much, much easier.
Yeah, but it's not. It's like being. I am a microcontroller monkey. I do a little bit of both, right? So I'm a microcontroller monkey
Oh,
too.
I do too, and I use that term not as an insulted term.
Yeah, no,
but
no.
It's just the way that the whole thing is presented that way to everybody. Like this is really easy to do. Get this microcontroller, hook it up this way, download this sketch, and away you're off and.
Oh,
But
for sure.
what have you learned along the way? But I think I've had a look through your channel too. I think you take a far more introspective view of things. You're not just a microcontroller monkey. So that the microcontroller monkey is the kind of guy who doesn't ever look at that. It doesn't ever want to know, why do I have to put a resistor on a light emitting diode? I'll just do it because you did it, right? You understand that, and it gives you an instant knowledge when you have to do something a little bit off the beaten track. You can deal with it, you roll with it, and you can go ahead with it. But a lot of folks can't because they don't.
Those people end up in my mailbox. I don't know if you get a lot of those people, but I get people emailing me. Like, let's say I have a video on turning a certain type of AT. Oh geez, I don't even remember now which chip, but basically the Arduino Leonardo chip, you can turn it into a HID, and so you can turn it into a keyboard. And so then I get lots of emails from people saying, "Hey, I've got this computer, and it's like 100 feet away, and I need to be able to switch this and switch that. Can you help me with this?" And like, they always just want the answer, because I'm like, well, first of all, I may seem intelligent on my videos, but I'm not really that qualified. And so I'm like, I've taken to asking them, okay, send me your code and I'll take a look at what you've done so far. And if I find anything, I'll let you know, but no guarantees. But as soon as you ask them to send you their code or what they've done so far, they never ever respond back, because they were just looking for that answer, like you were saying.
Yeah.
They just wanted someone to do it for them, type of thing. And yeah,
exactly.
It's up to them, but it's not up to me.
That's right. Oh, and exactly right. So I got a question very similar to that the other day on a video that I did a while back on a function generator. It was an inexpensive function generator that ended up coming to me with fake op amps in it, and it required the replacement of the op amps. But then the question I got was, can I modify this? Basically, he wanted to turn it into a radio, so he wanted to know how to, amplitude modulate the output. And I was thinking, well, the best thing to do would be look up out in Google how to modulate, how to do amplitude modulation. So I gave him a search string to look up, and then he wanted to know how do I get this function generator to produce tones. And that was a head scratcher. I was like, how does he know what a function generator is without knowing that that's what it does? It's basically
literally it. Yeah, it's
yeah.
It's oscillating voltages. Like, that's what it is.
Yep.
So you found some trash, because you also you made a video on how there's a function gen that was no good, but did you find anything that was really inexpensive but really worthwhile to buy? Is there anything you would recommend from the cheap pile?
As far as function generators go?
No, anything that through your journey that you picked up, very cheaply from AliExpress or Amazon that you were quite impressed with for the price.
Oh yeah, so yeah, there have been a number of things. I did recently a two-part series on these cheap little DSO oscilloscopes, and one of them was the ZWE 154 Pro, and that's an excellent little oscilloscope. Now I noticed some other people have done tests on it, but I don't know why, but what people tend to do is they'll take an output from a function generator, feed it through a 50 ohm cable and directly into the input of an oscilloscope, and then wonder why they're not getting the frequency response out of it. But I did it correctly. I actually loaded the other end of the cable with the 50 ohm load before going into the ZWE, and it does, like they advertise it as 18 megahertz oscilloscope, and it is an 18 megahertz oscilloscope. In fact, it'll go beyond that. The only restriction is you're coming up against the Nyquist limit for the sampling rate. So, but as far as the analog front end of that scope, it'll go well beyond it'll go. I think I tried it up to 24 megahertz or something like that. It was still fine. So, but they say it's an 18 megahertz oscilloscope. It really is an 18 megahertz oscilloscope. And if you buy the model, with the that comes with the probe and has the built-in battery, I think it's less than $50, and this thing is pretty amazing. Like if you were to even go back 15, 20 years, there's no way you could buy an oscilloscope that would give you that kind of performance for anywhere that kind of money. So it is a little bit of a gem. Like it's just a small little handheld oscilloscope with a 2.4-inch screen. So as long as you're not doing on-screen measurements and stuff like that, it's really good. Like you can see the waveforms. It has built-in measurements, a lot of them, so it'll do those for you. So you don't actually have to use the graticule on the screen to actually make estimates of the measurements. And it's got a fairly decent little built-in function generator too, although it doesn't have any way to change the amplitude of the output, and it's limited to some of the frequencies that you can generate with it. But still, I mean, you use a potentiometer on the output of that thing, and you've got then a way to adjust the output. And I won't get into it too much here, but you could also put in an offset voltage if you wanted to with a very simple external circuit. So I think that was the greatest little gem that I came across in so far. Another one was that little meter I got. So I went through the beginner's kit, and I've kind of added to it along the way, and I've added to it since then, and I still haven't done an update. There's another update I have to do. But I came across this little Kaiweets meter. It's just a very inexpensive little meter. I think it's about $20 or something like that, and it's a really dandy meter. I have it actually. I use it all the time right over on my soldering bench to check things quickly. And you'll see I've got an upcoming video where I use it to check the resistor values in the kit, because the resistors were just, they were marked horribly. They were so tiny. They were little 1/8 watt resistors, and the markings on them were either not there on some of them, or it's unreadable. So I used it quickly to test the resistance. And I use that little meter all the time. And for $20, I mean, for most people's use, if you're just getting into electronics, a little meter like that is fantastic. It's a gem. Now, and I tried other little meters that might have been, like half the price, like that 803 series meter that you can get off of AliExpress and off of eBay and stuff like that. Other people have gotten those. I think there are some places in the States that actually give them away for free if you go and buy stuff off them. But the one I got was a total disaster. It had some wrong resistor values in it and stuff like that. So I've eventually be able to fix it. But I mean, again, that's one of those things that it's a $9 meter, and if a beginner buys it and they use it, they're going to be totally disappointed with it, and they're not going to be able to fix it. I'm lucky enough that I have enough experience that I was able to fix the thing, and it's now sitting in my glove compartment in my truck just in case I need to check 12 volts here or there. But yeah, I have come across some gems, and I think that PCBWay 154 Pro was the best of those. And that power supply that we mentioned earlier, I think that was a real gem as well.
For the Kaiweets multimeter, are you talking about the HT118E, or are you talking about the smaller one? The
little one. The I think it's the HT or NT100 or something like that.
Okay, that's the one I don't have. Okay.
Yeah, the other one, the 118E, is a fantastic meter. I mean, that's all you need, unless you're going to work in a Cat 3 or Cat 4 environment. I mean, I know I have that really nice EV blog version of the Bryman 786, but I don't need that meter. I mean, it's nice to have, and I bought it, to support EV blog and Dave Jones and all that, and but that HT1180 is everything that is. It's got the same number of digits. The auto ranging on it is just as fast. It does everything that other meter does, except for it doesn't have a front end that would be safe in a Cat 3 or Cat 4 environment. But for the stuff I do, it's all Cat 1. I mean, I might go into my electrical panel, so Cat 2 once in a while, but I don't need Category 3 or Category 4 meter. And I certainly don't need... I one of the fuses on that meter I got from Dave Jones, and he sells fuses for them when he has them, but I contacted him. He said, "Oh, well, you can go buy the flute kit," and I went. I looked at the flute kit, and they wanted like $60 for a set of fuses, and you couldn't just buy the one I wanted; you had to buy two. And oh gosh, that's 1/3 the price of the meter for a fuse.
Yep.
So yeah. we don't really need meters that we buy all the time. And, you see a lot of, like, if you go onto EV blog forum, there's a lot of people there who are very snobbish about test equipment. And they won't even talk to you unless you got a Fluke 87 version 5 or something like that, minimum. Most of them have Fluke 287s and 289s and stuff. These are $1,000 meters. And they're using them as hobby meters at home. I suppose I'm to blame. I've got a Siglent SDM 3055, which is a benchtop meter. But it didn't even cost $1,000. I think it costs about $500 or something like that. But that's way more than I need. I do like it because it's a 5.5 digit meter, and I use it as my reference for everything else.
For sure.
Then again, I could live without it.
So I've been singing the praises of the HT118A. I think I have the A version. I don't know what's the big difference, but Kai Wheats reached out to me, and they wanted to send me this meter. But they reached out to me at a time where it was like every week I was getting another multimeter manufacturer wanting to send me a multimeter, and Kai Wheats wanted me to send. They want to send me their meter, and I said, fine. Whatever. Send me your meter. It looks the same as all the other ones. It has like a, Transformers style plastic overmolding and whatever. I'm like, it's just another piece of Amazon, whatever. But I said, you're going to put your money where your mouth is. If I'm going to test your meter, I need a way to differentiate it from the other ones. So here are a whole bunch of precision resistors, like 0.01%. And here's a voltage reference, and here's a project case, and I would love, this much money from you to buy these parts and to make this test box, and then I will use your meter and see if it's any good. And Kai Wheat said, sure. They said, here's the meter, and here's the money, build your test box. So I built the test box, and when I got the meter, I put it through the tests, and lo and behold, like, I can't even explain to you that it's on the video, but the 10K ohm 0.01% resistor measured 10K, 10.0K. The 100 ohm was 100.0. Like everything was exactly testing perfectly. And ever since then, I was like, like this thing might be good. And it's just been on my bench, and I've been using it like literally every single time I need a multimeter. I've been turning to the 118A, and it's been phenomenal. And the only reason that it's not my daily driver is because a subscriber sent me a Fluke 179, and I just like the way the Fluke feels in the hand. But both those meters are incredibly precise especially for the amateur level work that I do here at the workbench. So those Kai Wheats are an incredibly good value. But like you said, if you want Cat 3, Cat 4, forget about it. Like it does not have a legitimate rate, a independently tested rating, I should say.
Right. And, I think the only real difference between the 118A and the 118E is the E has an extra digit of resolution. So it's a 4.5 digit meter as opposed to a 3.5 digit meter. So it puts it up there along with the likes of, as far as precision goes, along with the likes of the Brymans and the Flukes and stuff like that. But and it's just as accurate. I mean, Kai Wheats really do make some awesomely good stuff. Even though aesthetically you're right, it kind of looks like a transformer kind of gone wrong. They could spruce that up a little bit, but I don't generally look at things that way. I mean, I'm not in it for the aesthetics at all. So that doesn't impress me one way or the other personally. I know a lot of people say, oh, that's an ugly thing. Yeah, I never really looked at it that way. It does a good job.
Yeah, I am a Fluke fanboy because I come from an automotive background, and our shop always had the Fluke 88.5, which was it's an amazing multimeter. And so being a Fluke fanboy, I found these cheap Chinese Flukes. So there's the Fluke 101 that Dave Jones took a look at, but there's also like the 15B, the 17B, and the 18B,
right,
which are the Chinese, for those listening at home, they're the Chinese market Fluke meters. So they're literally made by Fluke, literally in the same factories. However, They were never intended to be sold in North America. So people buy them in China and then resell them on Amazon here. But I got mine directly from China. So I did an unboxing 2 weeks ago, and all I'm missing for that video is to take a compelling thumbnail, right? Because it's an expensive video. I bought all these out of pocket. And but then next week, the plan is to go through and do extensive testing on each and every one of them. And the thing I found that was really bad with those cheap flukes is the test leads that come with them. They are the cheapest dollar store test leads I've ever seen. So I'm going to run the tests with the test leads included. I've got a good set of Fluke, I think they're Fluke 71, FL71 test leads from my 179. And then I got some, what's the company now? There's a company that sells really precision test leads that are recommended by the EV blog forum.
ProbeMaster?
ProbeMaster, there we go. I convinced ProbeMaster to mail them to me U.S. Postal instead of courier. So I got them way cheaper. And so I'm going to do the tests on all those meters and compare them to the 118A, the Kaiweets meter, to see, in the end, which one should you buy? Because the big difference between the Kaiweets and the Fluke is that cat rating is probably one you can trust on the Fluke, but not on the Kaiweets. So we'll see how it shakes out in the end.
Right. Fluke should stand by it. Although I don't know if you can get a traceable calibration on those 17 series, 15, 17, or the 101. So I think that that's where they would lack appeal to like industrial clients and stuff like that. And that's maybe why they don't sell them in North America, just in case somebody tries to, it's a Fluke, we'll bring it into our environment here. And then, somebody gets an electric shock and say, it was calibrated. Well, no, it's not a traceable calibration. So that would be the only issue I would say. But that, like we've been talking about, for us at home, our hobbyist uses things like that they're excellent meters.
Absolutely.
You don't have to spend. And Fluke did that way back. I think, I'm not sure how long it was ago, but I'm thinking in the 90s, they came out with the 70 series, which was kind of like their first foray into the everyman's multimeter. And, back around about the time they're still producing the 80, like the 8024s and the 8012s and the 8065s and all those meters, the 80 series, the 8000 series. And they were the professional level meters. So you get a handheld like the 8065, and they would sell that for about $300 or $400, even back in $1990. And then they came out with the 70 series, and it was like $50, $60, $70 for a meter. So I think that's maybe that these other ones here are kind of a carry-on of that. I know that they kind of dropped that 70 series, and it may have been for those reasons that, people said, it's a Fluke, we'll use it in these situations. And Fluke couldn't really stand behind it in the situations that people were then taking them into.
Yeah, possibly. Look, I know you are running low on time, and I do have a question that I throw to every single one of my guests. Do you mind if I ask you it?
Go ahead.
So the setup is, imagine you get like a huge grant, so unlimited funding to start the business of your dreams. It does not have to be profitable because you're getting funding, but it does have to provide a service or a product. What kind of business do you think you would start?
Oh, that's a very good question. I've never wondered about having endlessly deep pockets, but give me a second just to think through that.
Take your time, and there are no wrong answers. It's just kind of to tease out what's going on in your head.
Has to provide a service, eh?
Or a product or a service, and I mean those in the broadest sense of the word.
I think what I'm, at my stage of my life right now, I think what I might like to set up is a very open and approachable education system for the whole STEM thing. And, I know that we've been hearing about this for decades now, STEM this, STEM that, but I don't see it around. And I may not be in the right places to see it, but I didn't see it when I was living down in Toronto. I don't see it. I live up in a place called Muskoka. And there's nothing up here, absolutely nothing. I mean, they can't even get together an amateur radio club up here. So the opportunities for people in this area, and for a lot of areas, as far as I can see, and this again may just be Canada or the US, there's no opportunities for people to say, hey, I'd like to just go and learn that stuff, and go and learn it, and learn it at the most basic level at a rate that you can apply yourself to it. Sure, you can go to a college, and sure you take courses in electronics, but you have to do it at their rate. When they offer the course, you have to pay them a lot of money. You have to take the time out of your life to do it, rather than having kind of like a drop-in where you can go in there and you can hook up with a mentor and say, this is the kind of thing I want to do, and the mentor can take them through it and make it a pleasant experience for them to get there at their own pace. I think that would move the whole STEM movement ahead. And I think we need a lot more of that. We need a lot less people going on to the Flat Earth Society getting sucked into that sort of nonsense. And we need a lot more people putting their head down and using their time and their brains, rather than to propagate conspiracy theories, to come up with ideas and productive ideas. I think if I had a deep pot of money to dip into, I think maybe that would be a good thing for me at my age now. And I'm in my mid-60s, so I think I would be comfortable with that.
I mean, that sounds like a fantastic idea. I mean, I am a contract college professor teaching the automotive profession, but I also do workshops in high schools, and I think a lot of the issues is that these kids just don't get the opportunities to experiment. A lot of the problem with getting people interested in STEM or STEAM, if you're of that persuasion, is that I think there's so much going on in either in their lives or in their heads. It doesn't really matter. There's no difference, that they really don't get the opportunity to be touchy-feely with sort of like physical things. It's high school is very much like, these are the points we have to hit this semester, so make sure you learn them, and very little like, let's learn by doing, that kind of thing. And so I think anything, because like, for example, I gave a course, a full day, like a 6-hour course to a group of high school students about electricity in vehicles. So literally Ohm's law without a formula, just, saying, your battery's 12 volts, it stays 12 volts. Therefore, if your bulb has 0.5 ohms instead of 2 ohms, then it's gonna have more power. Like it is what it is. And
right.
The way they latched onto it was way easier than having them sit in front of a chalkboard and have them, practice, like moving around a formula. And so I think it wouldn't be a bad thing to extend something like a high school, to add in another year, because if you think about it, the further we advance our scientific and technological knowledge, the more we're asking these students and just people in general to absorb in the same amount of time. And so I think having time to touch, to feel, to experiment, to like I had, for example, I had the students build test lights. So basically a brake light bulb with three wires, a ground and 2 positives, one to a 2 ohm filament, one to a 4 ohm filament. They built these things, and we went out to the cars in the shop and we tested the circuits. So they got to see Ohm's law, to touch Ohm's law, because with one filament, the bulb was 5 watts. With the other filament, it was 20 watts. And what does 20 watts look like? What does 5 watts look like, feel like? What's it smell when you hold it in your hands? Your hands' oils get on it, and then it heats up, right? So I think I'm with you. I think more STEAM engagement is 100% the way forward. I'm with you.
Oh, absolutely. I mean, we definitely need more people doing that than we need, working minimum wage jobs in Walmart and stuff like that. Not that we don't need that, but they're trying to eliminate those. So what do people do? Like, our local Walmart here, they they used to have a whole row of 12 cashiers. Now they only have 2 or 3, and if you want to get out in reasonable length of time, you have to go through the automated checkout, and so they're these minimum wage jobs where you don't really have to know anything are going away, and it would be great if you had some inclination to try and do something, more. And I think, but people don't get access to it here in where I live. Like they've shut down all the music programs. There's only the one high school in this neck of the woods has a music program anymore, and they're talking about shutting that down. So, like I when I finished that series I did on the oscilloscopes, and I have some other test equipment that I've decommissioned myself, and I got in touch with one of the local high school science teachers, and I said, "Do you know any students that'd be interested in competing for this? Maybe doing a little competition, a little idea, a little project, or something like that." And no, don't know anybody interested in electronics at all.
Yeah, it's sad. Huh?
That's so sad. Sad. Yeah.
It's just something. This is the number one thing I can say about making YouTube videos, because especially short form content, because as much as the old crusty men in our vertical don't like short form content, this is what the youth are consuming. And if you show them something cool, they're going to want to know more about it. It's that simple. Whether it's blowing up LEDs 3 times before you get the right resistor combination, or
right,
whether it's showing that you can turn your function generator into a boost converter and go way over voltage if you add a diode and a like an inductor or something. You know what I'm saying? Like, if you show
diodes and capacitors.
Exactly. You show them something cool and they'll gravitate towards it. I think that's it's important to try to meet them where they are. And I think making YouTube videos is a great start. So, in a way, you're saving the world.
Oh, thank you. I'll do my best.
So I'm definitely going to encourage the listeners to go and check out your YouTube channel. I thoroughly enjoyed it, and I'm not just saying that to be nice. I'm not a genuinely nice person. Is there anywhere...
I'm nice enough.
Well, thank you. Is there anywhere specifically you'd want to send like someone, like what kind of video would you recommend them so that they get an idea of what your channel is all about? Is there one in specific?
I guess any of the beginner ones. So I have a playlist. So I have a playlist there called Beginners Electronics, and there's a bit of everything in there at kind of a more basic level. And if you wanted to go from there, I've playlists on doing repairs and stuff like that. The repairs I've obviously get into a little bit more sophisticated stuff that beginners might not be that interested in. But yeah, I would go with the Beginners Electronics playlist.
And I personally will put my hat in the ring if you are like me and you are interested in learning a little bit more in depth. Bill's definitely got some of that stuff. So I will personally link you to the op-amp learning series, because I found it very intriguing. It's pretty much the right pace. It tickles my brain the right way that I think I'll be able to learn this stuff. So I'll set that link in the description, as well as the beginner videos playlist link.
Well, you might be interested in a video that it's coming live today, where I take a digital IC and an operational amplifier IC and make something we're all familiar with out of it. So it's something of I found it just scribbled in the notes of one of my old books, one of my old university notebooks. We could make one of these with this sort of thing, and I saw that the other day when I was doing some more research on, especially on that 74 LS86. It was in the same notebook that I saw my little note on this, and I never acted on it, but I did the other day, and I made a video on it. So I think that's coming out at 4:30 today, which won't be the day that this was released. But anyway, you have a look at it and let me know what you think.
Sounds good. I'll link that one in the description as well, because by the time you're listening to this, it has been out, and I don't know how many views. I'm going to assume, let's say, we'll say 430 views. Let's see it go up above that from the listeners of this podcast, please. just guessing.
Well, thank you very much.
All right. Well, thank you so much for taking your time to join me on this podcast. And I hope everyone is going to go check out your stuff. And I hope to catch all you listeners on the next episode.
Thank you.